Okay, so I'm going to talk about the future. And of course, what I've discovered this morning is this is a future that's actually being realized right now. So I wrote this presentation last week and it is already out of date. So I apologize for that. So I'm the Science Committee Chair at ICES, have been for 18 months. Previous to that, I worked in the Marine Institute in Galway, and I was the WP1 leader right at the beginning of this project. So it's quite interesting to see how far you've come since I've left. No cause and effect. So I'm going to talk about quite a lot of things. It's a ramble through various things that came to my mind when I was asked to present this talk. So it's not nothing specific. It's nothing special. It's just what I think is where we need to go, and many of you are going there. So that's really cool. So I'm just going to jump into it. One thing before I do jump in: have any of you read the abstract for this talk? Well, thank God for that, because Maria put it into ChatGPT. I presented this. You see it on the screen, and she put it into ChatGPT, and it made me sound like God's gift. And so you know that AIs tend to be sycophantic to their questioners. This one really blew me up. So it is actually a wander through ideas rather than anything else. So let's go for it. So one of the things I think that Mission Atlantic was really about was doing all these case studies in different places and then cross-comparing, find out what happened in different ones in different ways. And I was with Debbie, we were running the synthesis part of this package. And I'm not going to go into this in any detail, but I think there's a lot of information to garner from the different situations, the different priorities, and the different things that are important in particular areas. And these are just a couple of examples of different places where you can see different, these are different pressures, and over there are different human activity sectors, and you can immediately see some differences. You know, the Celtic Sea is almost entirely dominated by, I think it's fishing. I can't remember where it is. Not wastewater. It's fishing. Yeah, and so almost everything comes from fishing, and that's because industrially Ireland is not particularly strong. And then you can see the Canary Current has a very different approach. And also this shows you one of the problems of letting 7 different groups loose on things is that in Ireland we had an enormous number of linkages, and in other places they had a fewer number of linkages. And so these things allow you to then do these cross comparisons, and I did a synthesis on this on commonalities and specificities. And then Sousa did something far more sophisticated and combined them all together. So you can learn a lot from these, both the commonalities and the differences between these different things. So that's one of the things I think is important and that should go on. Also within the work we did in those early stages, and I think needs to be pushed forward as well in everything else, is this, what I've called a pedigree, which is the quality of information you're taking. And I think, again, I'll cite Sousa here. I'm really deeply grateful I persuaded Sousa to join this project. And what they did here, this is the Brazilian version, where they looked at establishing what you were looking at in terms of, was it qualitative or quantitative data? Was it in your area or out of your area? Or was it expert judgment? And I fully agree with Susan's interpretation that expert judgment should be taken at face value. The experts can tell you whether they're making a wild guess or whether they're pretty certain of something. And the problem is that we do not have the luxury of saying we don't know very much about this particular thing, so we're not going to advise you on it. If you know something, in the current context, you have to advise on it with all the caveats that go with it. And this sort of thing allows you to understand the context in which you're doing that. And I think we should have this sort of thing part of the publications we produce. A lot of you, one of the things I felt was really important is projections of our IEA results into the future. What is likely to happen under a number of scenarios? I did actually go into, I did a lot of web searching, and I confessed to using AIs to help me with that. And I found precious few examples of IEAs being projected into the future. But I've also found several here this morning, which should have been in my presentation, but I guess are still unpublished and undeveloped. So this is absolutely critical. We must be ready to project what we do. So that's the California current, and one of the best developed IEAs in the world, and yet all I could find from that one was a single projection, which is not actually done by the IEA, it's done within the IEA. So they're looking at movements of centres of gravity up the current in response to temperature, and that's from this paper here. So it's really important to be able to start playing scenario games with this stuff, and we've seen a couple of examples already this morning. So if I did this presentation tomorrow, I'd have examples from this meeting, so congratulations to you. So obviously climate change comes in. Now, many times in the past when we were talking about this project, I personally was criticised and the project was criticised for not including climate change as one of the key drivers in the work we did. And I would still stand by that, because climate change has numerous and multiple effects on sectors, on the pressures they invoke, and then on the ecosystem components which are impacted. And if you were to roll that into all the ODIM that we did, what you'd see is almost a mess. You'd see a system where you couldn't really calibrate what was happening due to those factors. You maybe could, maybe you're statistically smart enough to do that, or maybe an AI could do it, but we felt at the time that wasn't possible. And you can see the sort of things that are going on here. So orange is a decrease, blue is an increase. I'm sorry, I forgot to put up the citation for this. And grey is where it stays together. And so you can see essentially what you'd expect, a lot of increases, but also decreases. So things are changing very fast and across the whole spectrum. At the same time, and we've seen some stuff about this already this morning, is that you're also dealing with changes in, so this is world fisheries and aquaculture. So I'm an ecosystem-based fisheries management sort of guy. And you can see in the projections, this is FAO, you can see in the projections for fisheries, it's not expected to expand dramatically. Aquaculture will be the growing food extraction sector. And so we have to start factoring that into our assessments as well. And you can do that once you understand, to an extent at least, the nature of the pressures invoked by aquaculture now, and then project them and amplify them. Same sort of thing. So this is blue economy stuff. So this is a projection from the World Forum on offshore wind. And you can see various categories of places where it's going on, but what you've got is a cumulative increase. So offshore wind is steadily increasing, we know that. It's currently a bit in a recess, and that's largely due to people on the other side of the Atlantic who are being a bit sceptical, or idiotic, depending on how you look at it. But you can see definite increases across the world. The dark blue is mainland China, which is really impressive, Europe, Asian Pacific and so on. So you can see that this is going to be an increasing factor. And I could name others. 30 by 30 MPAs will change the whole picture, not necessarily for the good. One of the arguments I have with NGOs is that they assume that any MPA is good, regardless. You know, you put an MPA on the top of this building and things will get better. Then projections of IEAs. Now we did see a few of those here. I mean the California current one was not one, but I'm trying to remember which one. Yeah, it was the Brazilian coast and the South Central Arctic Ridge, Central Atlantic Ridge. And so projections are going to be the key to how we use this stuff. It's great telling them what's happening now, but it's really important to be able to project it into the future. And that projection would have to include climate change. So this one's really, you can't read the stuff, I just pulled it out of the thing, but it's showing you the progression from short-term scenario, short-term scenarios at the top, business as usual, short-term, long-term, for sandwich turns, from pressures from wind farms, over here, and over here you've got all the pressures, or 10 pressures put together. I took this figure down, copied it into my presentation, and then I noticed that I don't see any difference between any of the only ones that are different are the two there on the top left-hand side. But the principle remains. is you need to understand the pressures in the context of all the other pressures. And that's the risk assessment that ODEM and other systems are good at using. I'm only going to talk mainly about ODEM because that's what I'm used to and what you've mostly been using. The second, this is a thing that we really wrestled with when we were doing all the original ODEMs, and when Debbie and I were instructing people on how to do ODEMs, we tried to make it quite clear that you were talking about the consequences of pressure A on ecosystem A. It wasn't about interactive stuff, what we called second order at the time. So this is an example. So you put up a wind farm, you increase the number of wind farms, you will almost certainly decrease the amount of fishing because you're closing areas off. If it won't decrease fishing, it will move it into other areas and create new pressures. And then theoretically, this is just theoretical, don't question this is just an illustrative example. Let's assume that wind farms cause less fishing. And if they do so, then things like pressure on the seabed will decrease because there'll be less fishing. Now, we didn't ask people to include that sort of conception in their ODEM analysis, but at the next stage, it becomes more important because you're trying to look at interactive effects. You're trying to look at the whole cumulative, and I hate that word, pressures on the ecosystem. So basically more E means less fishing means less seabed impact, question mark. But in our ODEMs we generally just think of put up a wind farm and it creates pressures. It doesn't enable other pressures to diminish. So make it spatial. Again, ODEM is not designed to be spatial. It's designed to give you an overall holistic picture of an ecosystem, but to be useful for management and for policy development, it pretty well needs to be spatial. You know, where do we put our management measures, closed areas or reductions in a particular effort, or don't allow wind farms, or whatever it may be? You do need to understand the spatial stuff. So this is just one I stole from Andy Kenny. Looks at the North Sea, and you can see the already complex picture. There's all sorts of things going on in here, and they're all interacting. And it's first of all understanding that they are interacting, and then try and understand the basis of this interaction. So this is another example. This is you've probably seen this picture any number of times, where it shows you the fishing pressure on the seabed in the marine environment, and this can then be taken in and used in interaction with other things. So we've seen several examples of this, but I think that's the next step for a lot of this analysis is to go spatial. And the big problem then is how you combine, so let's say, fisheries data that's collected on a rectangle basis with this sort of thing, or with oceanographic data which is collected at very high resolution. So that's the challenge, and Suze also indicated there are ways of dealing with that. Then the next one is make it cumulative. Now, I've already said I hate the word cumulative because it makes a lot of assumptions. It assumes that all these pressures are in fact cumulative. When I'm talking to students, I give the example of if you have a gravel extraction area in the ocean, and there are plenty of those, if you fish over the top of it, the pressures are not cumulative. You've got an already completely destroyed environment. You can't destroy it any further by fishing on it. So they're not necessarily cumulative. And I found this paper, it's a 2024 paper, and they were looking at interactions between ocean acidification and warming. And what they found was that the really quite startling stuff is that synergistic, where one multiplies the effect of another, occurs about 16%. Additive, which is what we all assume everything is, it's most of the stuff, the risk is always taken as additive, represents 40%, and antagonistic, where one pressure counteracts another pressure, represents almost half of the interactions. Now that, of course, is not extendable to everything, but it's an illustration of just in quite a simple domain that the picture is not any simple cumulative additive effect. And the one that really scares me is nonlinear, where any one pressure on its own doesn't really have much impact, but if you add one to another, it has an interactive effect where one facilitates the effect of another. So a recent example I saw was that we generally see climate change as causing coral reef degradation, and that's happening in 75% of the world's coral reefs. However, 80-odd% of those coral reefs are actually being mostly degraded by local effects, pollution, freshwater runoff, and so on. And it's quite, and probably it is what's happening, is that the first thing of the pollution impacts on the coral reefs are preparing them, if you like, to be seriously affected by climate change that might not have an impact without that second effect. So we've just recently had a workshop at ICES, which I sat in on quite a lot, and they looked at various ways of understanding. They still call it cumulative, but it remains additive risks. I'm not going to go into this figure in detail, but you've got interaction and consequence, you've got the receptor, the stressor, and the exposure. We use that a lot in ODEM, the overlap component. And then you've got the recovery and sensitivity, and we already saw representations of that. Combine those, you get an effect potential. Put them all together, you get an impact risk. And that's where we should be working, but it's how you put them together. And so this is just another example I lifted. It's from the CIA report, which is not yet published, but will be out shortly. And you could see different pressures, different sectors, which are causing different impacts on the marine environment. And then you can see different things that cause more pressure or less pressure. And it's looking at both short-term and long-term. So this is the sort of thing we need to understand what the multiple pressures, which is how I prefer to express it. And then you can put that all together, spatial and cumulative. I apologize. I'm never going to persuade the world to stop calling it cumulative, so I might as well give up. So this is a project that was a collaboration between the Netherlands and Ireland, looking at the effect of, it was an IEA, but focused on wind farm and birds. And this is the wind farm development area in the southeast of Ireland. And we looked at various risks for various species under different scenarios of wind farm baselines. This mainly used another methodology, which we haven't used much in this project, which has got the wonderful name of SciComm. Anybody old enough to remember the band Focus from the Netherlands, which did Hear 'em, Scare 'em? Anyway, SciComm is a new version of that same ODEM. It's in that same ODEM generations, and it is now explicitly spatial. So you can use that to develop a risk map to seabirds of wind farms. But you can also, that's exactly what Susa was talking about, where you use that first stage to identify the primary risks, and then you move on to focus on the specifics. So what I want to talk about now is stakeholders' perspectives for or within an IEA. So this is the classic five blind men looking at an elephant. And one of them sees a snake and another sees a tree. So you've got all these different interpretations of what you see. And thus far we haven't incorporated that perception of the public. We take a very scientist perception of the thing. So we'd of course see an elephant because we're very good. And one of the ways you can start looking at this is what's called collective intelligence. And I'm sort of doing that thing, when an expert is somebody who knows something 20 minutes before the audience they're speaking to. So I learned about this about a month ago. And classically, it's asking people to estimate how many marbles in that jar. And you'll get all sorts of people. You'll get 10, you'll get 1,000. But if you get 100 or 1,000 people to estimate it, take them all and then take the average, they get it right. That's what's collective intelligence. It's also called wisdom of crowds. And it uses this, it's got this model, pose a question, collect responses, and use an algorithm. It is different to what we do, which is called collaborative intelligence, where we collect all these ideas and then form a consensus. Now, what's really important about the first one, the collective intelligence, is it gives you error bounds. It allows you to understand the range of possible options around that, which has always been the big problem with a lot of the expert judgment stuff, is we can't give an error bound for it. So I think collective intelligence is something we should consider using. I would really like to see, how different people involved in the marine environment see the problem. We did an exercise with fishermen where we had already done the expert judgment, the expert, the scientists, and we then asked the fishermen to validate that for us. And their first response was, of course, to say, well, no, there's no pressure from fishing. And after a considerable day interacting with them, we said, well, yeah, it is. Yeah, you're right, actually. Or occasionally we got it a bit wrong. But that process allowed us to understand the variation in how people see an environment. It's not necessarily true that we were right or that the fishermen were right. What you need to understand is that variance of opinion, because it matters in an advice and policy domain, what different people think. You could also add policymakers to that, or you could add children who'll probably get it right. So yeah, that's a recommendation from me. And also I think we need to make it link, and we've seen examples of that here as well, of linking it to ecosystem goods and services, because that's how it will be understood by society and by policymakers. There's always the so what question. Somebody recommended to me when I was presenting my science to policymakers that I should always have one slide at the end that said so what. What should they take away from what I'm saying? And I think goods and services are our venue to do that. Debbie and I did that with the Celtic Sea one, and I think this is an example from our new Ecosystem Overview 4th Generation workshop that Jacob Bentley, who's known to many of you, did, his Adventure Bay Integrated Ecosystem Assessment. Adventure Bay is a children's book. And so you can do this with this sort of thing, is identify how these things link to different goods and services. And then again from Jacob's Adventure Bay Ecosystem Overview, which is here up on the right, you can see a whole series of interactions and then take them through to what it means to humans, how it actually links back to society. And that's where we need to have, I think it was in the WG ICE, they were explicitly looking at the social and economic relationships to these IEs. So, if you looked at the risks to the ecosystem, also look at the risks to the human products from that ecosystem. People care about ecosystems, but only in the abstract. The thing about litter being the thing that most people in the mid-Atlantic islands were interested in is because they care about it because it's right in front of them. If you ask them to care about Shannon Wiener biodiversity indices, they will find that difficult. You need to be concrete and precise. So I'll finish there. I just got hold of this presentation because it fits my own job very well. But what we are doing is herding a lot of cats that are all being driven by different things, mostly to get away, and they're intolerably cute. So thank you very much.
Intolerably cute indeed. So, so Dave, thank you very much. Do we have any questions? We'll put this out to the crowd first. I have a lot of questions, but I'm going to wait. So.
I never know what to make of that.
Yeah.
Was it stunning or was it boring?
It was exciting. Yes, please.
I like the
one sec, please. Microphone is coming.
The idea of the collective intelligence, and I've been involved in processes that involve consensus, and consensus always to me meant like giving up your opinion, and so you can see why you wouldn't have very large error bars on a consensus meeting. There might be no such error bars, but developing things like stock status reports where it's done by committee and everyone is supposed to agree.
Even if they don't.
Even if they don't,
yeah.
The consensus makes you change your mind. So yeah, I really found that an interesting concept. So I don't know how that would, it might be a way forward in certain circumstances, like you suggest.
Yeah, I mean, one of the things that hooked me onto it was that in Scarum they claim they can get closer to the actual variability. I'm dubious, but maybe they can. But this is actually where getting directly to it.
I also liked it very much, but I didn't really understand it. And you're drawing with the brain in the center part. Who is that brain?
The one in the center,
Yeah.
that's you. No, so, somebody has to, I mean, like, take the example of the marbles in the jar. Everybody gives their estimate. Some poor guy has to do the statistics on that afterwards. But he's not trying to derive a consensus. He's not like a chairman in a working group that's trying to get the consensual opinion. Everybody gives whatever they think, and then he makes the average or whatever central limit theorem you want to follow. So it's you as the scientist. Or maybe it should be a social scientist. Do you count as a social scientist?
Hi, Dave. Chris here from the IC Secretariat. Just a quick question on climate change. Often we've used climate change in scenarios and shown them to policymakers, and they don't really take them up. Are not interested because it's multi-decadal and things like that. You know, it doesn't seem immediate. But by using it now within the ecosystem overviews potentially and IEAs and linking it to impact risk along with a whole lot of other things, is that the way to make it matter, really? Because now we can talk about it spatially in terms of management for MPAs and offshore wind farms, you know, the risks due to climate alongside with everything else.
I'm not absolutely sure, Chris. I think, but we really have to get to, particularly in fisheries management, we have to get away from the idea you can do it all with a cohort tracking model. You know, there's a lot of drivers going on there, including climate change. So we have to start explicitly including the trade-offs, you know, what you're trading off if you do this. And the models are great at that. I mean, something like, again, my own experience, Ecopath with Ecosystem was deliberately designed to allow you to look at what would happen based on what you've seen. You know, if I increase fishing, I'll lose all the dolphins. And for me, that sort of information, if you can distill it into that sort of statement, you know, if you, my favourite is, you know, if you find there's 1 million tons of cod in the North Sea to fish, everybody will go yee-haw. But if you then say, yeah, but it'll kill all the dolphins and it'll trash the carbon stores, then they're required to explicitly follow that. And yet policy tends to be very single linear, but, you know, it just follows one line. You know, if we fish less, there'll be less fish. Ken already showed us that's not true, and that wasn't true, how many, 40 years ago? And we're still behaving like it's true. And I think, and so my preference from this would be to take the more clear trade-offs, and one or two. Don't try and show them a wholesale holistic picture ecosystem and say combined ecosystem risk of these 280 factors is huge. You just go for a few explicit ones, and that's why the whole idea of the scoping within ODIM was to find the key players. And then you use those to explore what's happening and present those as quite, I would say there's a third tier where you actually get those that are manageable in some sense using the tools we have available, and then make 2 or 3 or 4 trade-offs explicit. But good question.
Thank you.
It's also useless to suggest this when you've got about a month left to do it, but yeah.
I have just a couple of small questions.
I bet.
No. Okay. You hate use of the term cumulative. What can we use instead? It sounds like a cocktail to me.
Yeah.
That could potentially be toxic at certain levels. But
Yeah.
what would you use instead?
I prefer the word cocktail. But I think it's interacting. We know they may be interacting at one level or another. They may be, like that study showed, you know, 40% of the interactions are antagonistic. I mean, who would have expected that? I was surprised how many turned out to be purely additive. So, yeah, cocktail, interactive, multiple. You don't even know if they interact. So there are multiple pressures on a system.
But then the antagonistic interaction. magnitude of one just dwarfs the counteracting effect of another, so to speak. And so that
No,
they're
but
yeah.
well, by definition, what it would mean then is the pressure from A, regardless of how big it was, would be reduced by pressure B. So you wouldn't. I mean, I didn't explore it in great depth, but if they're antagonistic, it means one. It's a positive number with a negative number. So inevitably, the negative number will increase the positive number. I think. I'm not a good mathematician. Somebody help me. Mike, help me.
Very, very small negative, it can only move it so much.
Yeah, but it won't make it bigger.
Elliot, yeah. Oh, thank you. Thank you.
So,
Apologies.
thanks for giving us your thoughts and a meandering thought process, Dave. It was I appreciated that you didn't come with some massive agenda. You just walked through what you thought, and that was really interesting to see. And what I saw was like, these are things we could do. These are things we could develop. And my thought, maybe it's unfair, but maybe as a SciComm chair, maybe it's more acceptable to ask now, is oftentimes we have this, if we build it, they will come mentality. And so there's a lot of great ideas about how we could develop what we do in what you've presented today. How do you think we can improve or increase their utilization? How can we get people to pay attention or yeah, any
Okay.
thoughts on getting them used?
So my personal view, and this is also with my IC's hat on, is that it's important to understand that most stock assessments are carried out with the assumption of stationarity. And what everybody's been showing on figures here is evidence of non-stationarity. Everything's changing. The statistics are changing. The distribution's changing. If you look out there, there are so many things going on that are going to impact on fisheries. The simplest one I can possibly think of is the mackerel debacle in the North Atlantic. So the mackerel spread into Icelandic waters. Any Icelanders here?
Yes.
I'll let you off. So because the mackerel were in Icelandic waters, they said, we want some. The rest of the people who had them already said, no, you can't have them. So they took them anyway, and the mackerel stock has collapsed. And the Icelanders attributed that to climate change. So you need to understand all this stuff, because it undermines every assumption you've got in your stock assessment through to your management. So let's say the sole in 6J in the Celtic Sea decided to go and live in 6A, the west of Scotland. That would change everything about the management of them. They wouldn't be able to be fished in the original place, they wouldn't exist in the original place, they wouldn't be surveyed in the original place. But if we continue to assume everything's stationary, we do a stock assessment for that place and then say no fishing because there's no fish there. Now that if we get to that ludicrous final result, that would be a disaster. So we have to be prepared for the fact fish are going to move between management units, they're going to grow differently, they're going to recruit differently, and they're going to migrate differently.
All right. So, well, with that, we're ready. Well, let's say thank you very much, Dave. I actually have another question as we're bringing up the next speaker, but we'll take it later.